Hey you all, I hope everyone is alright. Today we will be talking about self-starting siphon. But for understanding that, we have to understand what siphon is. So basically, according to the definition on the screen, which states that a tube that is bent in the shape of an N with each end in the separate container at two different levels so that the liquid can be pulled up into it from the higher container to go down through it into the lower container. This is the definition of siphon and this is how a siphon look like. You can clearly see the small N-shaped tube which we talk about in the definition. But our topic is self-starting siphon. So look at its definition. The self-starting siphon tube uses the property of momentum, cohesion and capillary action to initiate pull water out of the beaker and initiate the siphoning process. So it uses three properties that is momentum, cohesion and capillary. And this is how it looks like. In figure 1, it is the complete setup with the jar and the tube, and in the figure 2, we see how the tube for the self-starting siphon looks like. Thank you.
Hi, I'm Darren, and I'll be talking about the workings and the day-to-day applications of a self-starting siphon. Since we've seen Clinton demonstrate the way a homemade self-starting siphon works just a few seconds ago, let me show you the how it works with the help of a diagram. What we have here is a glass that is filled to the point where the water level matches the point at which the straw opens out. The straw is also filled with water and nothing flows out when it is in this state. Why is that? Let's take a look. So at the entrance of the straw, that is right in the glass, let's say that it is h1 distance deep from the top. Let's divide the straw into two parts, calling the two parts the outer and the inner halves respectively. So the depth of the water from the surface of the container to the entry point is also equal to h1. Then we can say that the part of the straw from above the surface of the glass to the top of the tube can be called h2. Therefore, h2 plus h1 is equal to the total depth of the inside of the straw. Over here, on the outside of the straw, we can say that the distance from the top of the straw to the exit point is h3. Now let's talk about the pressures at work here. Now we've got a pressure, let's call this P1, that's proportional to our first height h1, which is coming from the inside of the glass. And this is going to cause water to go into the straw. But at the same time, we've got a water column h1 tall inside the straw, and this creates a pressure in the opposite direction, so then they both cancel each other out. Let's not forget about the influence of air pressure, which is pushing on the water in the glass. Let's call this P2. And if the straw was empty, it would generally cause the water to move into the straw. But there's also air in contact with the exit. Hence, there is a presence of air pressure at the exit point of the straw too. Let's call this P3. And the air pressure that pushes on the surface of the water is also equal to the air pressure on the exit of the straw. And hence, P2 and P3 cancel each other out. Now all we're left with is H2 and H3. Now if H2 is equal to H3, then the pressure going out of the straw into the environment is equal to the pressure going out of the straw into the container, and there is no movement or change in the water level, and no water spills out of the straw. However, if the water level of the glass is increased, H2 is lesser than H3, and there is a greater pressure out of the container, and since A2 it becomes lesser than H3, water will start to flow out until the water level is at the same height as the exit point of the straw. Now this was the working of a normal siphon. Let's talk about the self-starting siphon that was demonstrated by Clinton previously. We take an oddly shaped straw. At first, the siphon is full of air, but when it goes down in the glass, the water begins to enter the straw and pushes the air out. But if we put the oddly shaped straw in quickly, there is enough pressure at the entry point of the straw to push the water all the way to the top. But it can't make its way to across the bend, but the water still has a little pressure acting on it. So it is pushed a little ahead. Then it begins to go down. This particular motion is facilitated due to the acceleration due to gravity. So its velocity continues to grow and it turns at the second bend and it comes all the way to the top of the straw and then stops. But since at the beginning we had put the straw in fast enough, there is that extra velocity that gives it that extra little boost and that final push around the third bend, and this causes the water to flow out of the straw. And there you have it, your own homemade self-starting siphon. Now about the applications. One of the most day-to-day applications of a self-starting siphon, you could say, is filling petrol in our vehicles. We use our vehicles every day as a mode of transport to get around. They either run on petrol or diesel. So the petrol pumps use the principle of a self-starting siphon in order to fuel up our vehicles for a specific cost. It is also used in the flushes that are used in toilets. At a larger scale, they are also used in the municipal waterworks industry.
And now, for no reason at all.
To make your self-starting siphon, you'll need a full glass of water, 3 bendy straws, and 1 pair of scissors. We will be making an M shape. Now, one of the straws will be a middle bend. We are going to use it to ensure that one hump is higher than the other hump. I'm going to do that by cutting straw a bit shorter on one side of the bend, which should be about enough. Now, as said, I'm going to cut this side shorter, so this side hump will be a bit lower than this side. So let's cut this part a bit shorter. Now we'll cut this at a diagonal so we get a nice sharp point. Like this. Cutting a sharper point like this makes us easier to join them together. We'll do the same on this side. Now let's join them together. Let the plastic deform so that we have a nice airtight or watertight seal. Watertight seal is necessary. So if you are having problem doing that, use tapes to seal it. Now we are not quite done because we have to cut this shorter as we are going to submerge it in the water. And now we are ready. You can see it works fine and the water will keep coming out until the level of water in the glass is at the level of the opening of the straw outside. With this, we can play with pressure and understand what pressure can do with other forces combined.
A few moments later.